Internet Protocol, or IP, is like a set of rules that all devices follow to send and receive information over the internet. Every device, from a laptop to a smart light bulb, needs its own unique IP address so that information knows exactly where to go. It's similar to how a postal system delivers mail to the correct addresses. You are probably familiar with Internet Protocol version 4, or IPv4. It was the original system used to assign these addresses. Now, it's important to learn about the future of IP addressing with the latest version, IPv6. In this first of a 3-part episode of Cisco Tech Talk, I'll explain the basics of IPv6 next. The original system, IPv4, uses 32-bit addressing, providing about 4.2 billion unique addresses. It seemed like that would be plenty at its release back in the 1970s. Way back then, who would have imagined that each person and business would need so many unique addresses? They soon realized that there would not be enough. To make the IPv4 addresses last longer, the internet developed a clever workaround called Network Address Translation, or NAT. NAT allows devices inside a private network to share a single public IP address on the internet. It could be compared to an apartment building that has one street address with a lot of apartment numbers on the inside. This way, the mail carrier gets to the unit and can tell which unit to deliver to inside the building. Your router does this job, keeping track of which device inside your network is talking to which website or service out on the internet. NAT has been incredibly useful, but it's essentially a patch on IPv4's limited address space. It works, yet it adds complexity and can be less efficient for certain types of connections. One of the great things about IPv6 is that it makes NAT mostly unnecessary, because every device can have its own globally unique public address, allowing cleaner, faster, and more direct communication over the internet. Switching from IPv4 to IPv6 is like replacing a small city with a whole continent. It takes time. IPv6 doesn't just expand the address pool, it also makes networking more efficient. It can move data through the internet more directly, simplify connections without the extra translation work, and it has built-in support for advanced security features. It's designed for the future we've already started living in, one filled with billions of devices, cloud applications, and the Internet of Things. A lot of networks now run IPv4 and IPv6 side by side in a setup called dual stack. You might already be using IPv6 without realizing it. It works quietly in the background, making sure your devices can connect no matter how crowded the internet gets. Basically, IPv6 isn't replacing IPv4 overnight. They are working together, so the world can keep running during the upgrade. Now that you understand the need and benefits of IPv6, click the link in the description for part 2, where I'll explain how IPv6 addresses are built and how they work. Thanks for watching. I'll see you soon.